Step inside the dojo. Welcome to this explainer, where today we are treating the exam hall not as a place of panic, but as a discipline, a martial arts arena. We are tackling the Cambridge Mathematics 9709 syllabus, and we are going straight for the heavy bag, the notoriously tricky Section 3.5, Integration by Substitution. I want you to picture the exam room. The clock is ticking down. You can almost hear the scratch of pens and the nervous breathing. Now, picture two different martial arts students stepping onto the mat to face a past paper question. Let's say a really complex one from a recent paper. First, we have Alex. Now, Alex relies purely on brute force. When Alex sees a problem, he overloads his answers with raw mathematical facts. He's just regurgitating every single formula he memorized, completely lacking any analytical finesse. He throws 100 punches, hoping one lands. Then we have Sam. Sam is fast, but Sam is reckless. Sam rushes through the exam, completely missing the specific command word requirements the examiner actually asked for, and in the process, she drops vital method marks all over the floor. Look, neither brute force nor rushed panic is going to defeat a Cambridge examiner. To secure those top-tier marks, you literally have to flow like water. You must adapt your style to absolutely any question that comes your way. Over the next few minutes, we are going to completely transform your approach from flawed to flawless, ensuring you understand not just the basic how of the math, but the deep, analytical why behind integration.
Okay, let's dive into this, because the stakes here are absolutely incredibly high. What you're seeing isn't just an opinion from some teacher. It is a direct quote from the actual Cambridge Principal Examiner report. They specifically highlight that integration by substitution is one of the single most misunderstood areas in the entire mathematics syllabus. It is literally a trap that catches thousands of smart students every single year. You see, when our student Alex sees an integration question, he immediately panics and starts plugging in numbers without defining his terms. He's just swinging wildly. When Sam sees that same question, she completely skips writing down the derivative of her substitution, u, and just tries to guess the final simplified integral in her head to save time. Both of them walk right into the examiner's trap. The examiners aren't just testing if you can perform a mechanical trick you memorized, they are rigorously testing your theoretical foundation. They are looking for precise definitions, an understanding of the causal relationships within the algebra, and your ability to link this specific topic to other areas of the syllabus. So we are going right into the examiner's playbook to fix this exact misunderstanding right here, right now.
So we have to ask the central burning question: why do so many capable students lose marks here? Is it a lack of raw facts? Is it because they literally don't know the integral of cosine or e to the power of x? No, absolutely not. The theoretical architecture of this topic tells us that the failure happens entirely at the analytical level. Students are rushing. They are completely missing the analytical depth the examiners demand. You see, back in your IGCSE or O-level days, whether you were sitting the 0580 or maybe the 4024 syllabus, you might have gotten away with simply crunching the numbers and finding the right final answer. Even in the additional mathematics courses like 0606, 4037, or 4040, you could sometimes rely on raw algebraic muscle. But when you step onto the mat for the AS and A-level 9709 standard, and certainly if you're pushing into further maths 9231, the assessment framework fundamentally changes. It prioritizes analytical depth over superficial breadth. It's no longer enough to just know the integration rules. You have to explicitly prove your logical reasoning step by step on the page. You have to extract the relevant data, select the correct analytical framework, and execute it with crystal clear mathematical notation. If you don't show the work, you don't get the marks. Simple as that.
Here is our tactical map for today's session. First, we'll cover the integration trap. Second, core academic principles. Third, building your procedural framework. Fourth, the method mark strategy. And finally, top examiner warnings. Let's start with the trap.
Phase 1, the integration trap. Let's master the terminology.
The principal examiner reports reveal a glaring, fundamental issue across candidate papers year after year. Students consistently confuse key terminology. Think about it. Integration by substitution is essentially a disguise. You are evaluating complex integrals by changing variables to simplify the function. But the absolutely crucial part here is that final clause, requiring precise definition of terms before application. This is your very first defensive maneuver in the dojo. If you introduce a variable u onto your paper, but you fail to explicitly state what u represents in relation to x, or if you fail to calculate du dx before substituting it in, you are instantly bleeding marks. It's exactly like stepping onto the mat for a spar and forgetting to tie your belt. You are totally vulnerable. When you decide to substitute, say, u equals x squared plus 1, you must immediately derive that to find du and explicitly show the examiner how dx is being replaced. If there are limits on your integral, you must explicitly show the calculation of changing those x limits into u limits. The transition must be seamless, it must be logical, and it must entirely visible to the examiner grading your paper. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2, Core Academic Principles. Connect the concepts. Now we are getting into the actual theoretical architecture of the Cambridge assessment frameworks. Listen closely, because the examiners are not looking for a human calculator, they are looking for a thinker. The framework inherently prioritizes analysis depth. We can visually represent this as 3 distinct cognitive domains targeted by the assessment objectives. First, you have knowledge and understanding. This is just knowing your basic integrals, your foundational rules. Second, you have application, actually performing the physical substitution on the paper. But that third slice, analysis, that is where the top-tier grades are hidden. This involves real data interpretation skills. It involves extracting information from the context of the question and interpreting the deep relationships between the variables. It means when you are faced with a terrifyingly complex trigonometric integration, the examiner is actively assessing your logical reasoning just as much as your arithmetic. They are asking themselves, why did this candidate choose u to be the denominator instead of the numerator? Did they actually justify that choice through their initial algebraic steps, or did they just guess? Your analysis is what separates the average grades from the absolute top marks. So the crucial point is this. Linking substitution to other syllabus areas yields significantly higher marks. It's like a secret weapon. The principal examiner reports explicitly state that candidates who reference cross-topic connections achieve top grades. What does this actually mean for you? It means truly understanding how your integration substitution links right back to the chain rule and differentiation. It means knowing how it applies later on to calculating the volume of revolution or how it functions within kinematics problems. If you treat integration by substitution as this isolated, scary little island, you will continually struggle. But if you start seeing it as a connected conceptual tool that easily transfers to unfamiliar contexts, whether it's a wild trigonometry problem, a tricky logarithmic function, or a massive complex polynomial, you instantly elevate your mark potential. You stop acting like our friend Alex, who sees only raw, disconnected, memorized facts, and you actually start seeing the matrix of the mathematics. You start flowing.
Section 3, the procedural framework. Flow like water.
When you sit down, open that exam paper, and see a daunting 6-mark integration question staring back at you, you absolutely cannot panic. You need a structured flow. Your response must be completely automatic, logical, and deeply methodical. Here is the exact step-by-step methodology to achieve that flawless flow. Step 1. Deconstruct the question. What are the specific command words? Is it show that, or is it evaluate? They mean very different things. Step 2. Extract data. What is the function? What are the limits? Step 3, select framework. Identify the most efficient possible substitution for this specific scenario. Step 4, execute with clear notation. Write out your u, clearly derive your du dx, and handle your limits flawlessly. Step 5, present with correct terminology. Ensure your final answer is correctly converted back to x if it's an indefinite integral, or clearly evaluated to a value if it's definite. Imagine taking Alex and Sam's messy, red-inked papers and transforming them. As they follow these 5 steps, the red pen marks literally turn into green check marks. But if you skip a step, like Sam always does when she rushes to the end, the flow breaks, the logic crumbles, and the marks just evaporate. You have to trust this sequence. It is your ultimate shield against careless errors under pressure.
Section 4, the method mark strategy. Process over the final answer.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get back to the dojo, because this right here is where we shift your focus entirely from just sweating over the right final number to how you rigorously prove your work. The entire Cambridge system is designed to reward your process. If you accidentally mess up a minor final addition at the very end, but your substitution, derivation, and integration steps were logical and clear, you will still secure the vast majority of the marks. Process is king. To guarantee those vital method marks, we are adapting a classic analytical tool specifically for advanced mathematics, the Peel framework. I'm going to give you a 30-second speed writing challenge in your head right now to visualize this.
P is for point. Clearly state your chosen substitution. For example, explicitly write, let u equal sign of x. E is for evidence. Provide the mathematical evidence, which is your derivative. Write, therefore, du over dx equals cos x. The second E is explanation. Rewrite the entire integral substituting your new u and du, clearly showing the cancellation of the complex x terms. Finally, L is for link. Link it all back to the original context by performing the integration with respect to u, and then crucially linking back to the x variable or calculating the final given limits. If your mathematical paragraph follows this exact Peel structure, the examiner literally has no choice but to award you those method marks. You force their hand with your clarity.
And this brilliantly illustrates our ultimate goal, 100. Let's do a quick data scan challenge mentally. When you look at top-tier past papers, what is the core trend? The trend is that 100% of your focus should be on clear notation and logical reasoning. Imagine a visual progress bar on your paper slowly reaching the 100% mark potential. You absolutely do not reach 100% by chewing your pen, staring at the ceiling, and hoping the final simplified answer magically pops into your head. You reach 100% by rigorously communicating on the page. Every single equal sign, every integral symbol, every dx or du is a deliberate, targeted signal to the examiner that you are in total, masterful control of the mathematical environment. The theoretical architecture we discussed earlier absolutely demands this level of precision. When your presentation is flawless, you completely eliminate the cognitive friction for the examiner. You make it incredibly easy for them to just check, and give you a perfect score.
Section 5, Top Examiner Warnings, Avoiding the Traps.
Now, what's really interesting about this slide is the psychology behind the mistakes. We've scoured the principal examiner reports, specifically for 9709 mathematics, to find the exact recurring traps that cost students their grades every single session. We're going to do a Find the Flaw challenge right now. The top 3 warnings are right here on the screen. Warning 1, examiners report that students fundamentally confuse cause and effect in integration by substitution. Warning 2, students completely forget to check their format and presentation under time pressure. Warning 3, final answers are not specific to the context given in the original question. If you were analyzing a flawed sample paragraph of mathematics from our friend Sam right now, you would instantly identify these errors. You'd see her just swapping out a dx for a du without ever calculating the derivative. That is a massive flaw, confusing cause and effect. You would see dropped integral signs halfway down the page. That's terrible presentation. And you would see definite integrals evaluated at the end without ever changing the limits to match the new u variable. That's completely ignoring the context. These are the traps. And now you know exactly what they look like.
Let's neutralize that devastating number 1 warning right now. Cause versus effect. This is foundational mathematical philosophy. The cause is your mathematical trigger. It is the specific variable you actively choose to substitute, your u. The effect is the resulting, beautifully simplified integral that emerges solely because of that substitution and the subsequent careful derivation of du. If you fail to explicitly show the linkage between these two things, if you magically jump from a highly complex x integral to a simple u integral without showing the algebraic cancellation of terms in between, you are presenting an effect without a cause. Cambridge examiners strictly demand to see the causal relationship. The higher-order assessment objectives demand that you evaluate the alternatives and mathematically justify the sequence of your algebra. You must map the journey from cause to effect explicitly on the page, leaving zero guesswork for the person grading it.
Let's bring this all together and compare the flawed approach with the mastery approach. On the left side of the mat, we have Alex and Sam's techniques. Alex overloads with raw facts without ever evaluating the limitations of the formulas he's using. Sam rushes, completely misses the command word decoding, drops her formatting, and ignores the context of the limits. But on the right side is the mastery approach. These are the 3 rules that guarantee top marks. First, command word decoding. A master evaluates alternatives. They test a substitution mentally first to see if it actually cancels out the remaining terms before committing it to paper. Second, Peel framework application. A master applies correct formats, using that exact Peel structure we discussed to bulletproof their reasoning. And third, a time management matrix. A master doesn't rush, they pace themselves, drawing evidence-based conclusions that are completely specific to the question asked, ensuring every minute spent yields maximum marks. Your ultimate goal in that exam room is to always be consciously moving your thought process from the flawed, panicky column on the left to the calm, controlled, mastery column on the right. To truly lock this entire methodology into your brain long-term, I want you to use a visual story method. Encode the integration by substitution concepts as a sequence of events, like a movie scene. The original x variable is in trouble. It's way too complex, it's trapped.
Then the hero, you, arrives on the scene, which is your brilliant substitution. But you doesn't come alone. You brings their specialized tool, DUDX, the derivative. Together, working in perfect tandem, they dismantle the complex function, cancel out the messy parts, solve the puzzle, and return the mathematical world to normal. Visualizing this precise flow ensures you will never skip a step under pressure. And listen, this works. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries. But only if they practice consistently with our weekly videos. You have to put in the reps in the dojo. We've reached the end of today's dojo session. You've seen the trap laid by the examiners, you deeply understand the academic principles being tested, and you now have the exact procedural framework to dismantle any integration substitution question the Cambridge examiners can throw at you. The choice is now entirely yours. When you open that test booklet next week or next month, will you step into the exam hall like Alex, relying on a disorganized, panicky jumble of raw facts? Will you rush blindly through the paper like Sam? Or will you adapt, flow like water, utilize the Peel framework, and secure every single method mark you rightfully deserve? Keep evaluating your process and always be mastering the why behind the math. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to absolutely every comment. Like and share this video with a study partner who needs it. Ace the Exams, your Cambridge success starts here.